My name is Julie Nelson, and my final project for deep learning is DNA sequence classification by convolutional neural network. In this project, I mimicked a CNN used in prior work on two different data sets and achieved close to the paper's accuracy. The biggest takeaway I learned from this project is how important hyperparameters are for replicating experimental results. DNA carries genetic instructions in all living things. Because sequences contain so much information, it should be possible to use them to make predictions, but this is extremely difficult as there are lots of unknown features. But deep learning could automatically learn those features and make predictions based on those DNA sequences. My goal in this project is to create a CNN based off of prior work that takes in DNA sequences and outputs some class associated with that sequence. Some of the issues in replicating this paper is that the paper does not include any of the hyperparameters that they used. In addition, the paper only reports test error, so it's hard to know if their models were overfitting. We can't give the neural network raw sequences, we have to pre-process them. We're going to treat DNA sequences like text data. So we're going to take in a DNA sequence of A, T, Gs, and Cs. We're going to map each of those nucleotides to a numerical token, and then we're going to send that tokenized vector to the neural network. The architecture used consists of two convolutional layers that include ReLU and max pooling. Those are then sent to a fully connected layer that includes dropout, then softmax is applied, and a class is output. I stuck with this general architecture throughout all of my experiments. The first dataset that I applied my network to is the Splice Dataset, which contains sequences that are 60 base pairs long and belong to one of three classes. There are over 700 samples for each of the first two classes and over 1,600 samples for the last class. The paper achieved an accuracy of 96.2% for this dataset. My model had a test accuracy of 97.5%, which is better than the model in the paper. This means it classified 4 more examples correctly in the test set, which isn't a lot, but that's still kind of cool. The next data set is the H3 dataset, which contains sequences that are 500 base pairs long and belong to one of two classes, either positive or negative. There are over 7,000 samples for each of these classes, and the paper achieved around an 89% accuracy for this dataset. Unfortunately, I was not able to match the test accuracy from the paper. My best model achieved a test accuracy of 82.4%. I tested a lot of hyperparameters, and in general, the model was very prone to overfitting. I was able to get training accuracies of 90%, but the associated test accuracy never got over 83%. In conclusion, I was able to beat the paper's accuracy on the small Splice dataset, even if it was by a small amount, but I was unable to match the paper's accuracy on the larger H3 dataset. What this shows is the importance of the hyperparameters. I was unable to replicate the paper without knowledge of the hyperparameters researchers used. If I was to do this again, I would try to contact the researchers and get those hyperparameters.